And thank you everyone for joining. Michele here, and together with Stefan and Dimitri, we'll walk you through the automation customization updates for 2025, and then we'll go straight into the individual topics. I'll start with the updates for HyperMesh client. Then I will pass it to Stefan, who will cover HyperView and table view. After that, Dimitri will walk you through an update on the report module. And if time permits, I will wrap it up with a general update on Task Manager and extensions. So let's start with HyperMesh. The highlight on the HyperMesh side for 2025 is Python API recording. What we have in this release is an on-demand recording for Python API, meaning that a user has a start-stop button and they can record their desired action sequence in the GUI and then generate automatically Python code for automation purposes. What the code does, apart from capturing the actual actions, we also capture the entity selection logic that is used in the advanced selector, and I'll try to demonstrate it in a couple of minutes. The user has also control over the generated code. So there are a set of settings that they can switch on and off essentially, and control the output. Together with that and the useful tips that we put into the code, we believe that the user will have a really good sort of understanding of what's going on and also good control over the output. And last but not least, we allow parameterization. So the code that we generate, user can parameterize. In other words, they can replace the hard-coded argument values that come from the actual actions performed live in the GUI and replace them with variables in the Python code, and then obviously expose them as parameters of the script itself. For illustration purposes, here's a quick overview of the GUI feature of the recording. There you will see there's a recording toolbar at the bottom of the screen, which allows you to start and stop the recording. Once the recording is over, you'll be greeted with the recording dialog, where you can see all the recorded functions. The little hamburger menu here guides you to the output settings micro dialog. And then if you decide to output the code into the console, you will see the generated code directly in the Python console at the bottom of your window. So that's a very, very quick overview, but I'm sure you would like to see it in action. So let me go into HyperMesh session and let's see how this works live. In previous releases, we introduced a new ribbon, developer ribbon. So this is your entry point for the recording feature as well. Let me bring it over, and then you will have the recording icon here. Essentially, this opens or puts on the screen your toolbar, where you can undock it, redock it. All in all, you control the recording, the start and stop sequence. So let's go into it. Let me start recording, and as a quick demo, I will import a FemDeck. I will generate some changes. So we'll create a new component with a new property, and then organize elements into this new component, and then export the solver deck to see how this performs. We start by importing the file, and then let's say we want to create a new component and new property for the base. Right? So I'll go to model. I'll start from here. Create component, then we'll call it base. We'll create a new property for it as well. We can call it the same, new base, and we are happy with B shell. Let's go with thickness of 5.5 for change, and I'll pick an existing material. That's it, and we're happy with that. We can close it. And now, next step, as I said, we'll simply move or organize these elements from the base to the new component. What I'll do, I'll pick elements here, and I want you to pay attention to these steps, because this is where we do some extra work, which I believe is hugely beneficial for the user and also for the resulting generated code. So here I'm going to say I want to pick these elements by component. Okay, using the advanced selector, I will go here and we'll pick the elements from the base plate, right? And then using the O keyboard shortcut, I'll jump into the organize context, and I will say, yeah, I'm happy with this. I want to move these elements to our new component. Right, job done. And I will finish this recording sequence by exporting the solver deck here, and let's just call it modified. Done. Okay. And I can stop the recording. Once we stop the recording, as you saw in the slides, we open the GUI, listing all the recording functions. If I expand the full list, we can see each and every argument of this function. I can see the type, and I can also see the actual value that I used during the action in the GUI. What you can see in the last column is that parameter. So any of these arguments, I can assign a variable in my Python code and then expose it as an attribute, as a variable of the actual function. What we can do here together is, let's say I want to control the name of the new component and the property, the thickness, and also let's control the output name of the exported file. Okay, so I'll go to the parameters. By the way, you have two options. You can do it either from this tab, or you can directly follow a little pop-up from the recorded functions tab as well. I'll do it from here just to show you this approach. So we'll start with the thickness. That's a float. I'm happy with that. We can give it a default value as well, 10.0, and then move on with the next parameter, which I will call simply name. This will be a string. So here you can see we can choose from each and every type that the HyperMesh functions support. I don't need a default value. I'll keep it as it is. And then the last parameter will be, let's call it output file. Okay, again, it's a string attribute, string variable, so we can do it like this. And then I can assign them to my individual arguments. So I need to make sure I find them all. So here we created the new component, then we renamed it, right? So the new name we set goes here. Then we created a new property. Again, the final name definition goes here. So I can assign it to this argument. 5.5, that's the thickness. So I can give it the thickness parameter. And last but not least, I wanted to control the output file name, right? So I will go here, output file. And that's it. If I'm happy with this, I can make the GUI a bit smaller. And if I hit generate, by default, we print the code into the console where user can review the code, understand the outputs, and if they need, obviously modify it. For the purpose of the webinar, I actually created the code beforehand, and let me show it in the editor here because it's a bit easier to see, and also it provides the highlighting. So while we're here, I wanted to highlight a few aspects of the code. It by default is organized into a run function. Okay, that starts here. As you see, all these attributes or variables, they are then arguments of my run function. And if we look at them where they're used in the code, they're used anywhere where I wanted them to be used, right? Where we assign them as parameters. Same with the output file and same with the thickness. And here, because we specified the actual default value, we see the default value again as part of the Python code. I mentioned earlier on the slides that we also work with various comments and tips in the code. So the development team has done an amazing job of sort of guiding you through the code and giving you extra useful information. What we see here in this example is two situations. One, as we're deleting the model, HyperMesh will ask you, okay, are you happy with that? You haven't saved the previous model. It's a question. We can enable the option ignore pop-ups, take care of that. And also, historically, as we're moving and updating the API layer continuously, some of the functionalities are still recording the deprecated commands, which as we are switching to Python API layer, we are leaving those behind. But in order to keep kind of things continuous, we also have a function to enable deprecated functions. So again, in order to avoid having kind of a hard stop and make things as user-friendly as possible, you will see that there is an option to enable usage of deprecated functions as well. And while we're here, I want to point you towards this piece of code as well, where you can see that comparing to, for example, command.tcl, where historically that's where the user would start when creating TCL scripts for automation, we did not capture the logic how entities were populated on the mark. However, we actually did the operation. At the end of the day, if you looked at command.tcl code, all you saw was a mark populated using IDs of those entities. In Python API recoding, what we do for single single selection guide bars, we actually capture the logic. So if you remember during the demo, I was picking elements by component, and we pick component 6, and this is exactly reflected in the code. So we've got the component selection based on the ID, 6, and then the collection of elements is populated from this component selection. So the logic, the steps that the user performs in the GUI are reflected in the resulting code. Now going back to the code generator, we said, okay, let's explore the ignore pop-ups and enable deprecated functions. So what I'll do, I'll clear console here. We'll go to the settings and very quickly just pick these two options and close this, generate a new code. Again, just to make it easier for you to see, I'll go here. And the differences are that we use a different model class, the one that gives you access to the extra goodies and to the deprecated functions. And also, if I compare it with the original code, where we had this function here, deleting the model, that we know can trigger that pop-up. In the new code, using the option, we automatically feed in the agent answer next command, yes, which basically suppresses that pop-up, gives it the necessary answer, and the code runs without any user intervention. And with this code, if we go back to console, let's say we're happy with this, so I can close this, proceed, and I will copy paste this again into the console to make sure that it is actually treated as a proper code. Yep. And now I've got the code, I can run it. I can call my run function. As you can see the arguments, new name, output file, and if I'm happy with the default value of thickness, I don't have to change it. So what I'll do, I'll say modified base, and then we'll create new file in the temp folder. Let's call it new file GTA fem. Okay, and we can run the code and then check the results. So we've got modified base component with modified base property, thickness 10, which was the default one, right? And if you have a quick look at the resulting area, we've got our new file generated. So I'm happy as a user. I've got my Python code and I can work further with it. So yeah, that, ladies and gentlemen, is Python recording in 2025. I hope you will enjoy it. And with that, let's go back to PowerPoint, because the development team has worked on a few more goodies for you in this release, and I want to make sure that you're familiar with those as well. So I cherry-picked a few enhancements that are coming in HyperMesh Python API in version 2025, starting with the entity class constructor. In previous releases, there was a limitation where when you were creating a new entity, you could only pass an integer, float, or a string attribute value as name value pairs. So from 2025 onwards, we're supporting any attribute type, so there is no restriction. And in this slide here, you can see a little snippet of 3 different situations. So we're creating a node, and directly in the constructor, we are passing local coordinates attribute with a Python list. The second example is where we're defining a new property and directly passing it a material object as the material definition. And last but not least, here we're showing a set creation where we're passing as the IDs, as the list of entities defined there, a list of entity objects coming from the collection. So all in all, you can predefine everything in one hit. You don't have to create the object first and then follow up with defining the attributes in subsequent lines of code. The collection class itself has undergone some improvements. Up to version 2024.1, you will see that there is an intersection method or intersect method. We felt that the naming was not too, I guess, obvious or user-friendly, and we knew we wanted to introduce also a new Boolean operation. So in 2025.0, essentially the original intersect method has been renamed to filter, as it acts on the existing collection. And we introduced a new method, now called intersect, which essentially returns you a new object. So if you're performing a Boolean intersection between 2 collections, the intersect method will return a new third collection object, which will be the intersection of the 2. The contains method that allows you to check whether a collection contains a specific object, a specific entity, has been streamlined. Up till now, a user needed to pass an entity handle instead of the actual entity object. Entity handle is more of an internal concept, so we improved it and just made it more user-friendly. So directly you can pass an entity object to the contains method. And last but not least, collection by interactive selection now allows you to specify a message in the bottom left corner. So this is the widget that allows you to prompt the user to select entities interactively, and they will see a little message in the bottom left corner of the HyperMesh window. Entity attributes, that's a big topic for our Python API project. I think I mentioned it in previous webinars. We have around 200 entity types times hundreds of data names. We get over, I think, 10 or 12,000 altogether. So there's a lot of attributes that that we need to cater for, and we're continuously making improvements in order to support all of them ultimately, but also to support them in the right way, in a Pythonic way. The improvements that you will see in version 2025 are that we unified how we output attributes that work or that simply return a list of numerical values. Now every single one returns a NumPy array. We prefer this approach as it is memory efficient, performance efficient, and most importantly, it is unified. So every attribute that works with a list of numerical values, upon querying, it will give you a NumPy array. If you're defining this attribute, so setting it up works both ways. So you can supply an NumPy array, but you can also supply a plain vanilla Python list of values. Tabular attributes have been something that we really pushed for, and the development team has done a great job here. So we're now supporting tabular attributes in 2025, and we have removed the editability restrictions. So previously, until version 2024.1, any attribute that you can see in the entity editor as grayed out, we basically honored this editability restriction. We decided to remove this because it gives users more flexibility, and it is something that ultimately the customization gurus will need. So all these attributes are now controllable through Python API. And in general, that there's more and more stuff that we're pushing for, and more improvements will be coming in future releases with respect to entity attributes. And let me close this section by mentioning that we've also pushed for some new functions in this release. We introduced 3 new widgets, if you think about it: plain by interactive selection, entity list by interactive selection, and entity by interactive selection. All 3 of them can be used to interactively prompt the user to perform or to provide certain information. Plain by interactive selection is the little tripod, a manipulator widget that allows user to specify a plane or a direction, and it returns you a dictionary, a plain normal and plain base. Entity by interactive selection forces user to specify a single entity and returns a single entity object, and the entity list returns a list of specified entity objects in the selected order, which is important for certain functions where you generate, for example, a geometrical line from a list of nodes, or you're generating surfaces from a list of entities where the order matters. We also pushed and worked on some goodies for HyperMesh Post. So now the results plotted in HyperMesh Post can be queried directly in Python using a series of agent active plot control values commands that you see on the screen. And also users can now generate or define derived load cases using Python API. So all in all, I really hope that you will enjoy all the new stuff in HyperMesh Python 2025.0. And with that, let me pass it over to Stefan, who will walk you through equally, if not more, exciting news on the Hyper-V Python API front.
So my name is Stefan Eberhardt, and I show you the news here for HyperView and HyperGraph/TableView in 2025. So what is new? In 2025.0, here you see the legacy API classes, and this is what we covered in 2024.1. In 2025, we added the following. We added full set support. We have on the window and the session level the 3T export functionality. we added query support and brand new interactive selection. So let's start with the query. The query will be done by the query results tool. It will return an NumPy array. If you just start the query tool and then if you run it with the .query method, it returns the NumPy array and it will query the results which are displayed in the GUI. It automatically looks if scalar, vector, or tensors are plotted, and it will export all of them when they exist. The entity binding of the search, because behind there will be a collection created, will be the first one which will be found. So if it's a scalar, then it will be, for example, here it's element based. So the query will be, the entity binding for the query will be elements. The entity IDs will be automatically added at the beginning of the NumPy array of each row. When you want to query a custom, again, with custom settings, here I show an example. I do on top create an element collection, which the operator which all the values bigger than 0. If I have this one, I can create my query tool and assign the collector with the collection attribute. Then I can define a custom query. So set data source query, which is a list of lists. And here I can say I want to see element ID, contour value, component pool, element normal, whatever. The entity binding for this query is defined by the entity type of the collection. And all the queries from the TCL, from the existing TCL API are supported. If you want to see what is possible, just use the query tool and say with the method get data source info, and you get a dictionary which shows you the entity and the options which you have for these, how you can create your query. Concerning performance, when you want to query, the performance, also for bigger one, is comparable to the legacy TCL API. So here's some example on my machine with 64 gig. So if I query 100,000 entities and do 5 attributes, it runs basically in real time. If I go up to 1.5 million, same number of query properties, then it runs for me around 15 seconds. It proved to be very fast if you query only once, and if you want to do special math operations or filtering, do it on the big NumPy array. Here, some numbers. On the right side, I query everything according to my data source query into the NumPy array. Then when I have here, for example, 100,000 elements and 200 parts, I can create 200 sub-arrays, sub-NumPy arrays for each part, and do here some math operations on some columns. It runs nearly in real time. If I go up to 1.5 million and use around 1,000 parts here, then it runs are also similar to the query, like 16 seconds. Let's show this live. So I load here a model which has scalar, vector, and tensor results. I just create the query tool query and print the NumPy array. What I get here, you see, I get the NumPy array ID, scalar vector, the list of the vector, and then the tensor components. So when I do a more query, so now let's do a more advanced. Here I use the filtering and get an use the arrow box. So here I create an operator here and ask all the entities greater than 0. I create my query tool. I assign this collection created by this filter, and then I query, and I also want to see what kind of options I have here using the data source info. And you will see the NumPy array, it finds only in one part here all the results. And you see here all this, what I get here, element normal, etc. in this NumPy array. The data source info shows me here for what entity type what kind of information I can ask for this model. I quickly run here this NumPy array, the math, which I showed the code previously. It will load the model, run through this one, and you see loading the model goes fast. All the math and the 200 arrays and doing the math on it goes in real time. I create here, comes up, an Excel CSV file was created, and you will see here, this was the query which I defined in the code. The NumPy array, 60,000 elements, 200 parts. It runs over to just the math, and then I automatically saved it with as a result CSV. Good. Let's continue with the interactive selection. The interactive selection allows me to create a customized context where I can select my entities and get lists or collections back. This will replace this heavy to use legacy TCL selection panel script. So if I want to create an interactive selection just with defaults, I say interactive selection and run the select method, and I get a part collection back. So I can define the entity type of my selection. For now, it's part, node, and element. And the return types are collections, lists, or sorted lists of entity objects. The selection methods are single, window, and advanced selection. So I can click on elements, I can do a window selection, or use the advanced like in other context or idle mode. When I give here a little bit more example, a detailed example, when I say do the interactive selection here, for example, for type elements, and I want to use the modal options. The modal options blocks every GUI action beside the model movement, so zooming, rotating, and selecting, but all the other GUIs browsers are blocked. If I say modal true, this is the default value. I can give here for the interactive selection a message argument, and then when you start it, you will see before you start clicking the first time, you see the status bar in the lower left corner. I can use the mode multiple. Multiple always returns a collection, and window selection and everything is possible. If I use, for example, list or a single, then it returns a list of objects or a single object. So this one then returns a list, and you just have to loop over it. And I always got the objects. So this allows me then to do operations on these objects. Let's go into some live demos. Okay, here I create just in one line with default settings, create the selection object and run the method. And then I loop over what I get. So I run it, and you see the selection comes up, component. I can select here a window selection or a single selection and get here all the parts with, yeah. So when I want to do this interactive selection with a list, you will see I said, okay, block all the GUI actions, return a list, and give me this message, and then I loop over the objects of the list and give me properties like the ID and the coordinates. If I fire this up, you see here, select nodes for sorted list. My message shows up in the status bar, and I just can click my list objects and they will show up. Then we will turn now to sets. Set, we have now full support. Set here in this example, I create a set from an entity selection. The main command here is I create here, have here the set entity. If I create a set, the entity binding, the here top part has to be provided, or element or node, or so when I populate false, it will be an empty set. If I don't give this one, I get all the entities in the active model. Then I can add and remove entities by collection from this set. And then I can do the attributes, whatever you know from the GUI side. And you see here below, I loop over the thing and set the color of. And here I do Boolean operations. I get here all the parts and subtract the selection one and set. So this is just for visualization. I set some components and fire it up, and you will see the sets are created. If I want to see my set, and you see exactly according to my code, my part, 3 components, etc. were selected, and the attributes are taken. So let's go to the 3D export. We added 4 classes: GLB in PPT, H3D in PPT, H3D in HTML, and the GLB export. This covers all the attributes what we have now in 2025 from the GUI side. Let's show a quick example or two for H3D, for HTML export here, for example. This one creates the object export model H3D in HTML, and then I run this code, which all the properties, compression, result, etc. And then I will start here in the default web browser, just the HTML file created. And you see here on the status bar, model export in progress, please wait, and then boom, and it opens up in my default browser here. I want to export the GLB model of this one, you know. This one loads in a different view here with different results, and immediately creates and exports and opens up in my default viewer, you know, the GLB export. Now let's go to the last, to HyperView and Table View. So Hypergraph and Table View are basically together. So in 2024.1, we have nearly 100% coverage for Hypergraph 3D, the classic Hypergraph. Now we added the full Table View support in 2025. So this was on the window class, most of the functionalities on the window class, and we added 2 more classes, Table Rule and Table Overlay. As I said, full coverage with all these 3 classes. That contains CSV import, adding single cell values, etc., and multiple cell values via a dictionary. So I can place everything everywhere, just creating a dictionary. I can formatting the cells, text, background colors, to control table size, conditional formatting, overlay areas, and. So quick demo in detail. For this demo, I do use 2 classes, the window and the table rule class. I will import a table CSV. You see here on the lower left, the screenshot from this table CSV. It has no comma, so it has type symbols. So I can also use, like in table view, the delimiter function to do it. Then I can do all the formatting, auto-fit, text, background colors, etc. And then I add table rule with a cell list operator. So add the rule, set the values here, set the colors. And last but not least, the refresh. It changes to table view and pumps in the values and formats it accordingly. The last demo I want to show here is the interactive selection query, doing the math, export to table view, do the conditional formatting all in one shot, everything what we saw today. This is on the HV query on the table section here in the extension. So you will see when I run this, it will load the model and pings me, select the components. I select a bunch of components in the front where are more interesting results. I like 27 components. Let's show here. It's blocked. I have it with modal, so everything's blocked. It loads the model, it queries, and then in real time do all the stuff, creates the thing. I had some puts command which shows you I created this query, what I wanted to see. Then I did the NumPy array. I did the math on the NumPy array, you know, which is for each part, which calculates the mean, minimum, mean, and maximum value. For the mean, I had no formatting. For the others, I did some formatting, etc. You see, and then I put it all in a table dictionary, which says in which cell what stuff has to be pushed, and then this was applied on the table view window, and then I added also the conditional formatting rules here accordingly. Okay, of the session, and I give to Dimitri.
Yeah, we will talk now about the new stuff in the report module that we have in 25.0. And the new stuff, thanks to all the development that has been done, it is the document classes, which is the new classes for generating document files like Word. And these new classes that have been inserted are the doc text, the document, and the doc table class, which insert a text, an image, or a table inside the Word file. Each of these classes, in order to be defined, needs a content, which can be a text, an image, or a table object, as we know from the reporting module that already exists in PowerPoint, for example. Or it can be a string, an image path, or a CSV file, respectively to the class I want to use. For example, here, we generate a doc text, we use a text object, we need which is a document or a chapter object, and last but not least, a name, which is unique for this object in the whole document. Now you see here the structure of a document, of a Word document. First of all, to access the document class APIs, you need to import via the report.hwx types, as in PowerPoint, for example. And please notice that the classic way of importing module hw.report has been deprecated and will be removed in 26.0 completely. As I already told, you see on the right the classic format of a document. We create first a document object, and then we populate this document object using the parent attribute via chapters or via doc classes. Each chapter can have doc classes in it, which are children of this chapter. And the content is added hierarchically, meaning that like this, chapter 1 is above chapter 2 is above doc table 2, etc. And for the document and chapter objects that I already mentioned, in order to be defined, need a name and the parent. For example, the document doesn't need nothing. It doesn't need a name, but it's not necessary. And for a chapter, needs a unique name, and the parent which can be a document object, as you see here, or a chapter object. Last but not least, we have in the report session class, which already you know from the PowerPoint, we have added a new API, which is the paste API, which can copy and paste different objects, for example, images or text from different points that we have inside the document to another point inside our document. For example, using this API that you can see, the get children, which give us the types that we want inside the chapter or a document. For example, here I want all the images in chapter 1. Using the paste, I get all the images from chapter 1 and paste them in chapter 2, which is very powerful. And last but not least, I save the document as in PowerPoint with a similar command, the save docx, and I set the template using the .template property. Now let's go to, you see here, we have made a script which runs a demo. This, in fact, this demo, what it does is importing a file, importing a model, importing some results, creating some plot controls, take a picture using the capture image tool, create a plot control tensor, and another plot control using another simulation step. And by this, then after I have generated after I have captured all the images that I want, I can create my document. As I showed you in the slides, I create the document first, then I create some chapters, and then I start to populating using a doc text, a doc image. I change some attributes for the doc text. I can change the font color, the font name, maybe to calibrate the font size. I can have nested images or nested text inside a doc text. For example, I can, if I don't want to save another object inside the doc text, I can add some images or some text using these APIs, add formatted text and add image. I can set the alignment also of the text. Using the paste, I create another chapter, sorry for this. And last but not least, I paste all the doc images from the first chapter to chapter 2. And then I save. And you see here the result. You see the document with all the formatting, the contents, table of contents, table of figures, the table of tables, and then specifically to the properties that I have set for the doc text and the doc images, I get the document that I want. Here you see, here it is a doc text, a doc image, the nested doc image with the nested doc text, another chapter, and here it is a doc table. And here are the doc images that I have pasted from the chapter 1. And now we'll pass to Mikhail for general updates.
On the extension side, there are a few enhancements which we would like to make you aware of. We improved the version administration, which means until 2024.1, essentially, if you had multiple versions or iterations of the same extension, and by same extension, we mean an extension with the same name and same author, and you wanted to use potentially multiple versions across multiple versions of the actual application, HyperMesh, HyperView, you had to manage them manually. Okay. From 2025 onwards, we introduced a logic that looks at the minimum product version and the actual version of the extension. And based on these two parameters, these two attributes in the extension.xml file, we pick the most appropriate one. And these will allow you to work with multiple extensions across multiple versions for either testing purposes, development purposes, or simply, because you have all the versions accessible to you and you want to use them. We also improved the error handling and error messaging upon failed registrations. And last but not least, now we're going into quite a low level of detail, but if you are familiar with the definitions of the commands in the XML files, there is a variable extension_dir that allows you to define the Python functions and point them. This historically worked only for ribbon.xml, and so there were some limitations where you could use this variable. From 2025.0 onwards, you can use it in ribbon definition, toolbar definition, and in any command defining attributes, whether it's value list command, get command, set command, or any of these, as you see on the screen. So that's for extensions, and I'll close the session with the little enhancements on the task manager side, specifically on the edit process tool, where we now introduce save and save as. Again, small step, but certainly improves the user experience when you're working with the file. And that's it. That's from our side everything. Thank you again, Stefan, Dimitri, and yeah, thank you for joining.